All right, so now what we're going to be looking at is symmetry, zeros, and then maximum R values, so the maximum radius values. So the first thing we need to do is we need to determine the symmetry of the graph. I actually put this in. I'm going to make this a little smaller. And the symmetry of that graph, since it's a cosine, it's symmetric with respect to the polar axis, which we see that from 0 to pi. So our first step is we need to go ahead and we need to look at those values of pi from 0 to pi, and then we need to find the zeros and the maximum R value. So what we should be doing is we should be creating a table for the general y equals 2 cosine 3x, so that we can go ahead and graph a regular rectangular graph. So that would be the regular xy trig graph for this, so that we can determine those maximums and minimums between 0 and pi. So this is going to give us kind of a bit of review of, in general, graphing cosine. So first what we want to do is create our table. We need to figure out what our A is, which is 2. Our B is 3. So our period for that cosine graph is going to be 2 pi over 3. So looking from 0 to pi over 3, pi over 3 is in the middle, pi over 6, and 3 pi over 6, which is just pi over 2. We will actually need to keep going because we have to cover all the way to pi. So we'll know that everything after this piece will repeat. So after 2 pi over 3, we are looking at 5 pi over 6, and then 6 pi over 6, which is just pi. And so we only have to go that much further. So for our cosine graph, this is going to give us 2, 0, negative 2, 0, 2, and then 0, negative 2 at that pi. Going ahead and graphing the pieces, we technically, since we did the table, we don't have to find necessarily what the zeros and the maximum R value are because we can see it. But you guys can graph it without seeing it. Pi over 3, 2 pi over 3. I'll just cut them in pi over 3 increments. 1, 2. So at 0, we have a maximum. Then we've got our minimum, 0, maximum, 0, minimum. Rough, less accurate sketch. You guys actually have the graph for your notes. So we can see that our zeros are at pi over 6, pi over 2, and 5 pi over 6. And then our maximum is at 0 and 2 pi over 3. Those are going to tell us what our two maximums are. But we don't want to forget that actually we have this viewpoint of a negative 2 and a negative 2. But when we go and graph it on the polar grid, that's still going to take us out to a radius of 2 on our lines. So make sure to include pi over 3 and pi in. So the minimums are also maximums in this case because you could think about it as saying the absolute value of that y is going to tell us our maximums. So then that kind of gives us, it's going to have a radius of 2. So what we need to do is we need to go ahead and we're going to graph the function, and we're going to see the points from 0 to pi. Some of these points we already know, but then there's going to be some pieces in the middle that will help us find our shape. So we are going to have to cut it up into 12ths on this case. Because this isn't going to give us our full shape that we need, we will want to cut it up a little bit smaller. So let me make this smaller so I have room. All right, so let's go ahead and complete this table. We're going from 0 on those pi over 12 markings. So this is a longer looking table. 5 pi over 12. All right, once again, I encourage you guys to go ahead, type this equation that we are working with into your calculator so you can get them out. Obviously, we have some of the values, the fact that 0 is 2, and then we're going to have all those repeats. We're going to have 0 at pi over 6, pi over 3, well, negative 2. Hold on, there we go. I had things all missing. 0, 2, 0, negative 2. So all you have to do is find those pi over 12 markings. So go ahead, do those in your calculator, hit pause, and then come back. All right, you should be able to see that most of these are dealing with 1.4, negative 1.4. We have a lonesome 1 in there. So now we're going to go ahead and graph all of these pieces. We may have a couple things repeating, obviously, since we're going to see stuff at zeros, but let's go ahead and do this. 0, we're going to be out 1, 2. Then we're going to go ahead and mark all the way around. So I want to see your guys' effort on this, working through, marking all of these. And then go ahead, hit pause, and then come back when you've completed so that you can check your shape. All right, so that's the shape that you should have. Notice that I fixed an error. I was going off the book, and the book made a mistake, so this is a negative 1.4, or else, things wouldn't work. So this shape right here is actually, in polar world, called a rose. May not obviously look like a rose to you, but the type of curve is a rose. Roses in this case can have 3 or more loops that are all equal. So the requirement is that they all must be equal to each other. And so this one has 3. If I had 4, 5, or 6, those could also be considered roses as well. All right, that's it.